Welcome to Study Loop.
Okay, so this is the free body diagram for the crate. So the crate is experiencing three different forces here, which is normal force, force P, and the gravity. So if we consider the positive y-axis is pointing upward but perpendicular to the surface, and the positive x-axis is pointing along the surface but pointing upward. So therefore, we can decompose the gravity and the force P. So P sine 15 degree and W cosine 15 degree is the y components of gravity and the force P. And P cosine 15 degree and W sine 15 degree is the x component of gravity and force P. So therefore, in order to get largest allowable coefficient of static friction, we can make sure that the static friction or the maximum friction is equal to the net force along the surface. So therefore, have mu Sn is equal to P cosine 15 degree minus W sine 15 degree. So we know the normal force is equal to P sine 15 degree plus W cosine 15 degree. So when you have the coefficient mu s is equal to P cosine 15 degree minus W sine 15 degree over P sine 15 degree plus W cosine 15 degree. So we know when the crate is about to tip at point C, the normal force should be equal to 0. So therefore, at this point, at point C, the total moment should be equal to 0. So therefore, we have P cosine 15 degree times L minus W sine 15 degree times 1/2 L minus P sine 15 degree times L, and then minus W cosine 15 degree times L over 2 is equal to 0. Okay, L here is the length of the square, okay, which is the length of the crate, since the crate is a square. And the reason why the force that was associated with the gravity is multiplied by the L over 2 is because the gravity is acting on the center of the gravity of the object, okay, and which we know that the distance from the center of the gravity to the side of the square or the side of a crate is 1/2 L if the length of the crate is L. So therefore, if we divide by if we multiply by the 2 over L on each side, we'll eventually have 2p cosine 15 degree minus w sine 15 degree, and then minus 2p sine 15 degree minus w cosine 15 degree is equal to 0. So eventually we'll have p, force p is equal to w sine 15 degree plus cosine 15 degree divided by 2 cosine 15 degree minus sine 15 degree. So we know W, which is the gravity of the crate, is mg, which is 30 kilograms times 9.8 meter per second squared, which is equal to 294 newtons. So therefore, we have P eventually is equal to 255 Newton. So now we can determine the largest allowable coefficient of static friction. Okay, so we can just simply plug in back to the equation with the P value and the W value. So therefore, the coefficient is equal to 255 Newton times cosine 15 degree, which is so just simply times cosine 15 degree, and then minus 294 Newton times sine 15 degree over 255 Newton times sine 15 degree minus 294 Newton times cosine 15 degree. And this will give us the largest allowable coefficient of the static friction is equal to 0.486. Okay, so the corresponding magnitude of the force P is 255 Newton, and the coefficient of the static friction is 0.486. So therefore, these are the answers for this question.